This is part 3 of this video series. This section will document the steps to create an output file that will be used in the CoDeSys program. This program will take the current command from input program and prepare the command to drive a PWM output. It will then monitor the current feedback along with supply voltage to regulate the valve in current feedback mode. So section 2 focused on creating an input file, and that's what we're seeing on the screen right now. I'm going to go ahead and cancel that. We're going to go and create an output file. So it's very similar. Do a right mouse click on 0300 output devices, add an object. The object I'm going to call underscore 0301 underscore valve 1, valve 1. Keep it as a CFC, continual function charting. Hit OK. Just like we did before, I'm going to rename the object so I can get a hold of the name. I'm going to go up to main, highlight return, and paste in the 0301 valve 1. Close that, expand this. Just as we did before, whenever we do something simple, let's go ahead and do a rebuild all to make sure everything's okay. Very good, very good. So we've created an 0301 valve 1 program. What we're going to do is take information from the input device program and drive the valve. So the first thing I'm going to do is I'm going to add my valve driver block. I'm going to hit an F2 just like we did before. So standard function blocks, I'm looking for something called fast valve driver. Fast valve driver. Highlight the 3 red question marks. I'm going to type in coil 1. What's the variable? What type of variable is it? Fast valve driver. That's fine. Push this along so we've got a little more room. So I'm just going to start filling out my blocks on the left. To enable it, I'm just going to have it true all the time or enabled all the time. Now on other pieces of code, you may say, well, I don't want to enable the valve driver mode if I've gone outside of a voltage range. In other words, if it's a 0.5 volt to 4.5 volt joystick and somehow you get 0.3 volts or you get 5 volts, you know that something has happened in your system, so you may want to turn off your outputs. But in this particular case, we're just going to have it true all the time. As far as the command milliamps, we want to bring the signal that was derived in the 0201 potentiometer. We want to bring this signal right here. So what I want to do is I'm going to go ahead and do a rename of this because I want this name, 0201 potentiometer. Come down here to my valve 1, do a control V and then hit dot. Now in my other screen you can't see this, but on the other screen it's all the variables that was derived out of that program. So I'm going to select command A. So the variable name is 0201 potentiometer dot command A. Could have keyed that in if you'd like, but I like to do as much copying and pasting as I can to make sure I don't misspell things. Okay. Supply voltage. We've got a variable called supply volt that monitors the power supply to the controller. So it makes current changes based on supply voltage. Okay, go over for that. Analog input feedback. Well, we want to see the variable that we have for that. We've derived in the backbone file, so I'm going to go back to I/O. So I've got a feedback, analog valve feedback that we were created in the backbone file. Create that here. Okay. I like to have things lined up. That's why I keep lining things up. Digital input monitor, we don't need. ISA-P, this helps us with the PID settings for the fast valve driver. And we recommend using a value of 0.5 to start tuning with. Then you can tune from there. There's more information on the in the user manual on how to tune a PID loop. And then the coil resistance. So the coil that I'm going to use today has a resistance of 7.1 ohms. So we have that there. Okay. Let's do a couple outputs. The first one is going to be a real world I/O. So I highlighted my question mark. It's going to hit F2. Go down to I/O. Look at, we've got two outputs, either a frequency output or a ratio output. Frequency is, as you recall, we had a value of 200 as far as a frequency, an output frequency, dither frequency coming out of the controller. If you wanted to change that frequency dynamically, you could use the frequency variable, but we want to use the ratio. So I've got the ratio. And then I also want to see what the current feedback is, and I'm going to throw that onto our service tool. So let's do another output block. Do an F2. This time, this is going to be it should be a variable. OD current coil 1. There we go. Okay, just like we did on the input section, we're going to go ahead and renumber everything. So I'll come over here and we'll do a right mouse click in the white area, do order everything according to data flow. Once again, this one's only got 3 numbers, but on the larger programs, you may have a lot more. It's just a good habit to get into to renumber everything before you try to compile. From there, I'm going to do a project rebuild all. If everything's fine, we still get 0 errors. Excellent. All right. This concludes part 3 video on ECU output file creation.